Yeah, good evening. Good evening, Fraggy. Good evening, good evening. Yes. Good evening to all. Yes. Good evening. They can leave a message in the group. The class has started. Leave a message. Yeah. Another question. Find the maximum number of students among whom 1001 pens, 910 pencils can be distributed in such a way that each student gets same number of pens and same number of pencils. Once again, find the maximum number of students, maximum, highest, greatest. If you listen these, if you read these words in the question, immediately what you have to do, what I told you to do, the maximum number of students among whom 1000 pens and 1910 pencils can be distributed in such a way that each student gets same number of pens and same number of pencils. Yeah. We need to find out a number. We need to find out a number x. There are 1001 pens and 1910 pencils are there. So that it should be distributed to these x students, so that each student will get same number of pens and same number of pencils. Then what will be the maximum number? What will be the maximum number of students such that these 1001 pens and 1910 pencils can be distributed equally to each and every student. Okay, na? So what we have to do? We need to find out HCF. We need to find out HCF. Yeah, good. HCF of, I think 91 is a prime number. $91 is a prime number. Is that right? $1,001, 91. 91 ones are 91. 9 1, 11, 91, 0. And here also 9 10, 91. Ones are 91, 0, 0 times. Okay, na? So there are total 91 students will be there. Total 91 students will be there. Okay. Each student will get 11 pens, 10 pencils. Each student will get 11 pens. Each and every student will get. There are total 91 students. Each student will get 11 pens, 10 pencils. Okay, right? Good. Next question. Again, find the least number of square tiles required to tear the ceiling of room 15.17 centimeters long, 19.2 centimeters broad. Least number, least, minimum. If you heard these two words, what do you have to find out? Find the least number of square tiles required to tear ceiling of room. Yeah, LCM you have to find out. LCM. So find out the LCM of 15 meters 70 centimeters. Length is 15 meters 17 centimeters. Breadth 9 meters 2 centimeters. So convert both into centimeters. 1517 centimeters, 902 centimeters. Find LCM. Find LCM, children. LCM of 1517 and 902, how much it will be? Fifteen 70 will go in which table, right? It goes in which table? 1517. Eleven table, right? No. Fifteen 17. 12 plus 2 14. See 13 table. 13 1 are 30, 2 1. Again 1 are 30, 87. No. 15 meters. 15 meters అంటే 1 meter 100 centimeters na. 1 meter is 100 centimeters sahasra. So 15 meters means 1500 centimeters plus 17 na. 41 table. 1570 goes in 37 table or 40, both are prime numbers only. 37 41s. 37 41. 37 prime number, 41 is also prime number. Then 902. 902 41 table. 41 twos are 82. Nice. So HCF 42. What is LCM? (41), 22, 11s. So this is 41 into 2 into 11, and this is 37 into 41. So LCM will be 37 into 41 into 2 into 11. 37 into 41 into 2 into 11. 33374 है. Yeah. (814) వచ్చింది. Triple 374, you got it. LCM. What is the question? Find the least number of square tiles required to prime the CB. Then what is HCF? (37 into 41 into 2 into 11 by 41 is that was HCF. 37 into 22. How much it will be? 74, 74. 840. The answer is given as 814. Means LCM by HCF. LCM by HCF, we are getting 814. But answer is wrong, I think. 814 is given in RS Agarwal. But I'll explain it again tomorrow, because in my view answer is 33374 only. That many tiles are required. 33374. Why 814 is given? Just I'll go through it and I'll come back again. Next question. 3 measuring rods, 64 centimeters. 3 measuring rods, 64 centimeters, 80 centimeters, 96 centimeters. 64, 80, 96 centimeters. They are the lengths of 3 measuring rods. Find the least length of cloth that can be measured an exact number of times using any of the rod. So this is 64 centimeters rod, 80 centimeters measuring rod, 96 centimeters measuring. 3 rods are there. Now what is asking? Find the least length of the cloth. Least length of the cloth that can be measured an exact number of times using any of these rods. Means without having any gap, we can measure that cloth exact number of times. Then what will be the length of the least length of the cloth? So the word least we got it now. We need to find out LCM. So find out LCM, children. We have 3 different measuring rods, 64 centimeters, 80 centimeters, 96 centimeters. Okay. What will be the least length of the cloth that can be measured using these 3 rods exact number of times without leaving any gap? Yeah, 960 centimeters. So convert into meters, it will be 9.6 meters. 9.6 meters. Previous sum also, in my view, answer is 33374 only, not 814. I will recheck it. I will come back to you again tomorrow. So not tomorrow in the class. (64), yeah, 960 centimeters. That is 9.6 meters. Correct. We need to calculate LCM for this. Next question. An electric device make a beep after every 60 seconds. Another device make a beep after every 62 seconds. They beep together at 10 a.m. One device beep after every 60 seconds, the other device beeps after every 62 seconds. Together they have given a beep at 10 a.m. in the morning. Now question is, they beep together at 10 a.m. At what time will they beep together at earliest? Morning 10 a.m. they beep it together, both the devices. Again, at what time they will beep together? This is what he is asking. There are 2 electric devices gives beeps. Okay, na? First one gives after every 60 seconds. Gives a beep after every 60 seconds. Second one gives a beep after every 62 seconds. So together they have given a beep at 10 a.m. in the morning. Tell me at what time again together they will give a beep. At what time? So what we have to find out? 10 a.m. they given that. We need to find out their LCM. 30, 15, 5, 62, 31. So LCM will be 2 square into 3 into 5 for 60, and for 62 2 into 31. So LCM will be 2 square into 3 into 5 into 31. How much? 1860. Sure, eh? 1860 seconds. After every 1860 seconds, both the devices will give beep together after every 1860 seconds. Okay. Now 1860 by 60. After every 31 minutes, both the devices will give beep together. So, in first time they give a beep at 10 a.m. together. Now 31 minutes is added. So 10:31 a.m. they will give a beep together. And after that 11:02 a.m. After that 11:33 a.m. like that and so on. In the same way, traffic lights at 3 different road crossings change up every 48 seconds, 72, 108. 48 seconds, 72 seconds, 108 seconds. The signal changes. Traffic signal changes at 3 places. First place, signal changes after every 48 seconds. Second place, signal changes after every 72 seconds. And third place, it changes after every 108 seconds. Now, all the 3 lights at the same time they changes at 8 a.m. in the morning. 8 a.m. in the morning, all the 3 traffic lights changes the signal. 8 a.m. in the morning, all the 3 places or all the 3 junctions, the traffic signal changes at a time, means together. Now again, at what time together the signal changes in all the 3 junctions? What we have to do? Again, same as previous problem, we need to find out the LCM. Find out LCM. So 48, it will be 2 cube, 2 power 4 into 3. 48, 2 power 4 into 3. And 72, 36, 18, 9. 2 cube into 3 square. And 108, 54, 27. 2 square into 3 cube. So what is the LCM? 2 power 4 into 3 cube. 16 into 27. 16 into 27. Is it 482 or 432? 432. So, in all the 3 junctions, after every 432 seconds, traffic signal changes together at a time. Now 432 by 60, how much there? 432 by 60. 6 sevens are 420. 1, 2. So, nearly 8 hours, 7 minutes, 12 seconds. Correct. 8 hours, 7 minutes, 12 seconds. After every 432 seconds, the traffic signals changes at a time. So it changes at a time, those 3 changes at a time at 8 a.m. in the morning. Again they will changes at 7 minutes, yes. 7 minutes, 12 seconds. After every 7 minutes, 12 seconds, they will change together. In the same way, there is another problem. There is another problem. 6 bells commence tolling together at tolling interval and toll intervals of 2, 4, 6, 8, 10, 12 minutes respectively. 2, 4, 6, 8, 10, 12. 6 bells are there. First bell will ring after every 2 minutes. Second bell will ring after every 4 minutes. Third bell after every 6. Sixth bell after every 12 minutes. Okay na? Now what you have to find out? In 30 hours, how many times they toll together? So if there is a 30 hours time is there, in these 30 hours, how many times these 6 bells toll together? So we need to find out LCM first. Find out LCM. Why? Let me tell you. Why we need to find out LCM? The first bell rings after 2 minutes, 4, 8, 2, 4, 6, 8, 10, 12, 14, 16, so on. These are the intervals. And second bell, 4, 8, 12, 16, 20, 24, 28, 32, like that. All the 6 bells. If you observe for these 2 bells, this is the least common multiple. So we need to write the timings for each and every bell. Then we can find out one, 2, 3, 4, 5, 6. Again do 1, 1, 3, 2, 5, 3. 1, 1, 1, 2, 5, 1. 2, 1, 1, 1, 1, 5, 1. 5, 1, 1, 1, 1, 1, 1. So how much? 30, 120. So 120 will be the least common multiple of all these 6 numbers. 120 will be the least common multiple of all the six numbers. So after every 120 minutes, all the 6 bells toll together. After every 120 minutes. 120 minutes means 2 hours. After every 2 hours, the bells toll together. Okay na? So in 30 hours, 30 hours means how many twos? 30 hours means how many twos? 15 are there. So 16 times plus 1 we need to add. 16 times they will toll together in 30 hours. Okay, then? 16 times they will toll together after in 30 hours. 120 minutes is the least common multiple of all those 6 numbers. 2, 4, 6, 8, 10, 12. So that means all the 6 bells will toll together after every 2 hours. Every 2 hours they will toll together. So in 30 hours, 30 by 2 plus 1, 16 hours. 16 times they will toll together. Okay, na? Right. So this chapter RS Agarwal done. Okay na? Next week we will go ahead with another chapter. Thank you very much. धन्यवाद.